This video covers several examples of adding and subtracting rational expressions when there isn't a common denominator. Before we do these problems with rational expressions, we're just going to start by looking through what we used to do when we had fractions without common denominators. So we would want to find a common denominator between these two. We talked a lot about finding the least common denominator last week, and we're still going to continue to do that. Looking at these two, I can tell that the least common denominator is going to be 36. And I don't really want to spend a lot of time going through that, so we're just going to go with 36. Now, if I'm going to turn this into 36, I would need to multiply the denominator by 9. When I multiply the denominator by 9, remember that we also multiply the numerator by 9. And so this fraction actually ends up being 9 over 36. Very similar, when we want to change this to have a common denominator of 36, we need to multiply the numerator and denominator by 4. After we do that, then we can actually add these two together. So this was just a little reminder that anytime we multiply the denominator by something, we also have to multiply the numerator by the exact same thing. We also need to know how to find a least common denominator, so if you were having a little trouble with that, here's another example. First thing we want to do is we want to factor both rational expressions. So this first one, the denominator, I can factor out a 4. When I factor out 4, I'm left with x minus 2. The second rational expression, I can factor out 4 again, and this time I'm left with 4x minus 1. To find the least common denominator, you write down the entire first denominator. So I'm going to write down 4x minus 2. And then I want to look in the second denominator to see if there's anything I've already written down. So if I've actually already written down 4, so I don't need to include it again. But I haven't written down 4x minus 1, so I do need to include that. So this would be my least common denominator, 4 times the quantity x minus 2 times the quantity 4x minus 1. Now we're going to combine the two ideas I've shown you. So we're going to combine what we did with the fractions and finding the least common denominator. So first thing I want to do for this, make sure I can't factor these denominators, and I can't, they're already fully factored. Then I want to figure out what my least common denominator would be. Again, you write down the entire first denominator. You look at the second denominator to determine if there are any matches. There aren't, so I need to include the entire second denominator as well. So my least common denominator is going to be x minus 5 times x minus 2. If I look at this first rational expression, the denominator already has the x minus 5, but doesn't have the x minus 2. And I need it to have both in order to have a common denominator. So I'm going to multiply the denominator by x minus 2. Remember, with our fractions, whatever we multiply on the bottom also has to be added to the top. I'm just going to carry down my addition sign, and then I can focus on my second rational expression. This time in the denominator, I already have included the x minus 2. However, I need to add in the x plus 5 to make this my least common denominator. Remember, anything you add to the denominator, you also have to include in the numerator. Now that I have a common denominator, I can make this one really large addition problem. So I'm just going to write this all together. Once you've done that, you want to simplify the numerator as much as you can. So you would distribute your 7, and then you would distribute over here twice. So this would be x times x is x squared, x times 2 is 2x. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. The denominator is going to remain the same, and we want to leave it factored. Last thing we would want to do, we would want to combine any like terms that are present in the numerator. I'm going to also rewrite so that it's in standard form. So I'm going to write this x squared first. Then I have 7x plus 2x minus 5x. So that would be 4x. Lastly, I have negative 14 minus 10. That's negative 24. The denominator I'm going to leave as x minus 5, x minus 2. Our second example is going to start the same way. We want to start by figuring out what the least common denominator would be. Again, start by writing down the entire first denominator. Look to see if there are any matches that don't need to be included in the second denominator. If I look, there aren't, so I also need to include x minus 1. Therefore, my least common denominator is x plus 3 times x minus 1. If you focus just on the first part of this expression, I have 2 over x plus 3. In order to have my least common denominator, I also need to include x minus 1. Anything I add to the bottom when multiplying, I need to also do on the top. I'm going to carry down my addition sign. Similarly, on the other side, I have 3. X minus 1 was already in the denominator, but I need to include the x plus 3. Anything I'm adding to the bottom of this fraction also needs to be added to the top. Once you've done that, you can rewrite this as one larger addition problem. So, the denominator is going to be quantity x plus 3 times the quantity x minus 1. On the numerator, I have 2 times x minus 1 plus 3 times x plus 3. We would want to simplify the numerator by distributing. So 2 times x is 2x, 2 times negative 1 is negative 2, plus 3 times x is 3x, 3 times 3 is 9. The denominator stays factored as x plus 3, x minus 1. Then I want to simplify by combining any like terms I can combine. So I have 2x plus 3x, that's 5x. Negative 2 plus 9 is positive 7. And the denominator is x plus 3, x minus 1. Just as a reminder, if I ask you to list any restrictions, I would want to list right here, if x were negative 3, that would make the denominator 0, so x cannot equal 3. Sorry, negative 3. And if I were to list a restriction for this part, x could not be 1, because 1 minus 1 would get me 0, and the denominator can't be 0. In this next example, I'm going to need to factor my denominator first just to make sure if I have any matches for my LCD. The first rational expression is fully factored, but the denominator on the second one is not. So this is an a equals 1 problem, so I'm looking for factors of negative 40 that add to be negative 3. Negative 8 plus 5 would get me negative 3, and negative 8 times 5 would be negative 40. So when I factor this, I would have x minus 8, x plus 5. Once it's fully factored, I can write down my least common denominator. Again, you want to write the entire first denominator, which is x plus 5. I want to look to see if there are any matches, and there's already an x plus 5 present here, so I don't need to include that. However, left over, I have x minus 8, so I do need to write that down. So my least common denominator is the quantity x plus 5 times the quantity x minus 8. I want to rewrite so that both of these fractions have my denominator that I need. If you focus on just this first fraction, I need to include an x minus 8. The x plus 5 is already present. Anything I add to the denominator also has to be added to the numerator. If you look at the second fraction, the denominator is already the least common denominator, so I don't need to make any changes to it. Then I'm going to rewrite this as one entire problem. So I have x plus 5, x minus 8 on the bottom. On the top I have x plus 7 times x minus 8 minus 7x. I need to start simplifying my fraction, so I would distribute. And I'm going to have to do that twice. The first time I distribute, I get x squared, then negative 8x plus 7x minus 56. Then I also have this minus 7x. Then I'm going to combine my like terms. So the like terms I have are negative 8x plus 7x minus 7x. Really, that's just going to cancel out these 7x's, so I have x squared minus 8x minus 56 over x plus 5 times x minus 8. Again, if you had to list any domain restrictions, we can't have a denominator of 0, and if x was negative 5, that would make this a 0, so x could not be 5. And right here, if x were 8, the denominator would become 0, so x could not be 8. In this next example, we're going to start very similar to the others. I want to fully factor anything I can. I'm noticing that these are very, very similar, so I'm going to start by just rearranging. I'm going to rewrite this first denominator so that the x is listed first and the constant is second. So I've just switched their places by doing this. And I'm going to leave the second one as is. Again, these are very, very close to matching. I'm just noticing that there's a sign issue. If I factor out a negative 1, then my denominators would match, and that will make this problem much easier to start off. Then I can list out my least common denominator. So my least common denominator, you're going to list the entire first denominator. So negative 1 times x minus 9. I want to look and see if there are any matches in the second one. There is, so I don't need to include that. So this is my entire least common denominator, negative 1 times x minus 9. If you look at the first fraction, the least common denominator is already the denominator, so I don't need to add or change anything there. In the second denominator, I just don't have the negative 1, but I do have the x minus 9. If I add a negative 1 to the to the denominator, I also need to add it to the numerator. Now I can rewrite this as one larger problem. So I have 1 minus negative 1 times 5. The denominator is negative 1 times x minus 9. If I start to simplify my numerator, negative 1 times 5 is negative 5. One minus negative 5 is really like adding, so I would have 6 over negative 1 times x minus 9. If I had to list any domain restrictions, x cannot equal 9. And another way to write this, we don't have to include the -1 out in front. We could just write it as negative quantity x minus 9. So this is just a more simplified version. Here's another example. Again, you want to start off by factoring the denominator. The first denominator is already fully factored, so we don't need to worry about that. However, the second denominator is not. I want to look for factors of 20 that add to be -9. And those factors would be -5 and -4. So I'll rewrite this to be x minus 5 times x minus 4. Then we're going to write down our LCD. Again, you write the entire first denominator. So I write x minus 4. If I look at the second denominator, there's an x minus 4 present. I don't need to rewrite that, but I do need to include this x minus 5. So my least common denominator is quantity x minus 4 times the quantity x minus 5. Focusing on this first fraction, if I look at my denominator, I notice that I have the x minus 4, but I'm missing the x minus 5. So I need to add it. Anything I add to the denominator has to also be added to the numerator. I'm going to carry down my addition sign. If I look at the denominator of this one, the x minus 4 and x minus 5 are both present, so I don't need to add anything to this fraction at all. Then I can rewrite as one larger problem. I want to distribute to simplify. 5x times x is 5x squared. 5x times -5 is -25x. 7 times x is 7x. 7 times -5 is -35. I also have this plus 3x. Then I want to combine any like terms that I can. If I start with my x squareds, I just have 5x squared. Then I have -25x plus 7x plus 3x. Altogether, that's -15x. Lastly, I have -35. I'm noticing on the numerator I could factor out a 5. If I factored out 5, I would be left with x squared minus 3x minus 7. The denominator would still be x minus 4 times x minus 5. If I was asked to list domain restrictions from this first set, I could notice that x cannot equal 4. If it was 4, that would make the denominator 0. Right here, x cannot be 5, so those would be my domain restrictions. In the last example, again, I can factor one of my denominators, so I'm going to start by doing that. I'm looking for factors of 24 that add to be -10. And those two factors would be -6 times -4. So I'm going to rewrite this as x minus 6 times x minus 4. To figure out my least common denominator, I'm going to write down the entire first denominator. If anything matches exactly in the second denominator, I don't want to write that again. However, I do want to write anything remaining. So my least common denominator is x minus 6 times x minus 4. Focusing on this first part, I notice that my denominator is missing the x minus 4. So I want to write that down. Anything I add to the denominator has to also be added to the numerator. And then if I look at the second fraction, I notice that the denominator already matches the least common denominator, so no changes need to be made. I can now rewrite this as one entire problem. And then I can start simplifying. I'll distribute the numerator. So 5x times x is 5x squared. 5x times negative 4 is negative 20x. 1 times x is 1x. 1 times negative 4 is negative 4. And I still have this plus x on the end. I want to combine any like terms. If I start with my x squareds, I only have 5x squared. Moving on to my x's, I have negative 20x plus x plus x, which would be negative 18x. Lastly, my constants, I have negative 4. If I needed to list any domain restrictions, I would notice that x cannot be 6 and x can also not be 4.